Thanks everyone for standing around the corners of the room, and apologies people that couldn't get in. Isa and I are delighted to welcome all of you to this NeurIPS tutorial on application development using LLMs. Both Isa at OpenAI as well as I at Deep Learning AI Fund have had the privilege of working with many people building large language model applications, and so we hope to share some of the practical tips with you. And after our presentation, we also have a distinguished panel of researchers and builders that with Ante, Tadze, Meredith, and Graham that I hope will also deepen everyone's understanding of how to build applications with LLMs. Here's the agenda for today. What we hope to do is help you understand how to build applications using LLMs, because this is a new way of building AI applications that is very powerful and allows you to get things to work much faster than was ever possible before. So the agenda for today is talk a little bit about LLM basics, not to teach you how to train an LLM from scratch yourself, but to make sure you have enough of a mental working model for how LLMs work so that you can use them effectively. And then talk about some examples of applications. Isa will have a lot of insights to share on how to write prompts and share some exciting cutting edge developments on tools for building applications. Then we'll also talk about some practical tips for building applications and wrap up with future predictions in closing before we go on to the panel. So, I think one of the tricky concepts to get about LLMs is that they're a general purpose technology, similar to supervised learning and reinforcement learning, these other tools we love. And that means that LLMs are useful for numerous applications. So today, there are many businesses using it for document Q&A. Many businesses are using this to build many different flavors of customer service bots. It's being used over and over to summarize messages, to route messages. It's being used in verticals like to process legal documents or medical documents. I use it all the time as a copy editor. There are also new forms of entertainment popping up, new forms of games, new forms of online companions that are being created. So this one technology, LLM, is useful for so many different applications. This is what I think of as the AI stack. At the lowest level is maybe the hardware or semiconductor layer. And very capital intensive, very concentrated, but clearly, right, certainly some businesses are doing really well. And then with every wave of technology, what I've seen is that a lot of the attention is focused on the tools and infrastructure layer, right? So a lot of attention on what OpenAI is doing, what Google's doing, what AWS, Azure, and so on are doing. And this seems to happen with every technology layer. Every time there's a new technological revolution. But it turns out that for the people building tools in infra, and I run Land AI, which does computer vision tools, but for the businesses providing tools in infra to be successful, almost by definition, there's another layer that's got to be even more successful, which is the application layer, because the applications built on top of the tools in infra, they better generate even more revenue so that they can afford to pay the tools and infra businesses. So the focus of today's presentation is really on how you can set yourself up to build exciting applications using LLMs. First thing I want to go over is basics of LLMs. Some of you may be familiar with this. Bear with me, we'll get through this quickly, but I want everyone to have enough of a working mental model of how LLMs work, because that affects the decisions you then make later as you're building whatever application you have on top of these LLMs. But text completion using a base LLM will be if you give it a prompt like I love eating and ask it for completion, run it once, may say bagels with cream cheese, my mother's meatloaf, out with friends, and that's the text completion. And this is called a base LLM, which mostly predicts essentially what's the next word on the internet or what's the next word on your as observed in your training set. And the base LLM is built with supervised learning, in which we create a data set and have a transformer network repeatedly learn to predict the next word. So if one of the data sets has scraped off the internet a sentence like, my favorite food is a bagel with cream cheese, then this becomes a set of training examples with supervised learning, where given the input, my favorite food is the right answer that the transformer tries to predict is the word bagel. My favorite food is a bagel. The next word is with. Favorite is bagel with cream, and so on. And when you scrape a very large data set off the internet and other sources, kind of, 100 billion or sometimes more than 1 trillion words, and create a data set like this and train a neural network, then this gives you an LLM based model, which is, which can be very good at predicting the next word on the internet. Right? Now, when you use ChatGPT or Bard or Bing Chat or other products, they don't just predict the next word, they learn to follow instructions. So the next step, so with a base LLM, this is what you can do. You can give it a prompt like, once upon a time, a unicorn, and it will, complete the story for you, right? And this is what, GPT-2, GPT-3 did. But it turns out that if you give a base LLM a prompt like, what is the capital of France? It will try to predict what's the next word if it has seen this on the internet. And for all you know, this may be part of a quiz on the internet. So completion to what's the capital of France could be, what's the capital of Germany? Where is Mumbai? Is Mount Fuji or whatever, taller? Because this is what you see on the internet. So to make an LLM follow instructions, which is what many of the leading LLMs do these days, certainly, ChatGPT, Bard, Bing Chat, follow instructions. They just predict the next word. The next step is instruction fine-tuning, in which you would come up with a large data set of prompts, like what's the capital of South Korea? Capital of South Korea is Seoul. Write a haiku poem, there's a haiku poem. Help me brainstorm some fun museums to visit in Bogota. So he has some suggestions. So as well as tell me how to break into Fort Knox. And it can say, I can't assist with that. So have some refusals as well in this data set. And given a large data set of prompts, instructions, as well as attempts, written by a human to follow the instruction, you can then take your base LLM, which you had trained on 100 billion or 1 trillion words on the internet, and further run gradient descent to fine tune it to this instruction following data set. So given this, help me brainstorm some fun museums to visit in Bogota. What's the next word? Sure. And then after that, here are some, and so on. And with a data set like this, if you continue to train the algorithm, for a much shorter period of time, maybe weeks, then you can prompt it to say, what's the capital of France? And it will have learned to follow instructions. France's capital is Paris. So with this, you end up with what's called an instruction-tuned model that doesn't just predict the next word, but learns to follow instructions. And then to shape a mental model of the LLMs that you use and hopefully will build applications on top of, there's one last step to make, which many companies implement in various different flavors to make these models safer. So such as the 3 H's, right? Honest, hopeful, and harmless. And common way to do this would be RLHF, which you may have heard about, but I'll just give a one slide description of what RLHF actually does, which is, first step of RLHF is to train a model to predict answer quality. And this is a reward model. So to do that, you would write a prompt, advise me on how to apply for a job, and have the LLM generate a bunch of responses. And we say, I'm having help. Here are some steps to follow. Or it may say, just try your best. Not that helpful. Or it may give a horrible answer. It's hopeless. Why bother? And then ask people to score these answers, say on a scale of 1 to 5, giving the more honest, helpful, and harmless answers a high score, 5, and the more useless or even the harmful answers a low score, say 1. And given this data set of answers and scores, the next step is to train a reward model that mimics how humans assign scores. And the reason we do this is because human judgments are expensive, but once you have a reward model that mimics how humans are judging the answers, you can then judge a lot of LLM outputs. And then the final step is to have an LLM generate tons of answers and use the reward model to score all of these answers, and then to tune the weights of the LLM to increase the odds of it generating the higher reward answers. And so through this process called RLHF, and there are many other flavors, like RLAIF and many other flavors, but RLHF, maybe the basic algorithm, you can tune an LLM to be more honest, helpful, and harmless. So less likely to say, emit toxic speech, less likely to express kind of very negative, undeserved stereotypes or biases, less likely to give out explicitly harmful instructions, right? So, and then just one technical detail. Those of you that know RLHF know that typically we ask humans not to write scores from 1 to 5, but we ask people to rank order pairs of answers. But other than that, this is mostly an accurate description. But with humans judging, do you prefer answer A or answer B? That also gives you a way to learn a reward model. And the goal is to learn a reward model that is consistent with how humans are ranking it to express their preferences. And that is RHF. And so with this understanding, I think you probably know most of what you need in order, to as you're building on top of LLMs, to use them effectively. But just one more technical detail I want to cover, which is I've talked about the algorithm as predicting words. It turns out that the LLMs today are actually trained to predict tokens, and tokens are either words or word fragments. So a tokenizer starts with, say, every character being its own token, and then repeatedly merges tokens that occur together frequently, so that common words end up becoming tokens. So the example, my name's pretty common name, Andrew, would be one token. And somewhat less common words like translate and programming are 2 tokens. And an even more rare word like tonkatsu, is in the Japanese dish, right? Tonkatsu ramen. In the case of this tokenizer, is 4 tokens. And roughly, if you use, OpenAI's tokenizer or other tokenizers, rough rule of thumb, 1 token is maybe 3/4 of a word. And so the number of tokens is, maybe 33% bigger than the number of words. And what I want to do is, if you have not yet done this, I want to show you, maybe just how easy it is.
Can you speak up?
Oh, thank you for that reminder. All right. So what I want to do is show you, if you haven't seen it before, hopefully how easy it is to prompt an LLM in code, right? So, this is the OpenAI interface, and don't worry about the code. We'll the code syntax you can get from somewhere. Import OpenAI, load my API key. There's a little helper function, where I tell it, there's a system message, your hopeful assistant. So Isa will elaborate on the system message later. We can tell the LLM what role you want to play, and then plug in the prompt and let's say, tell me a joke. And then, right, why don't skeletons fight each other? They don't have the guts. Not bad. Similarly, Google Palm, include Google's generative AI, configure Palm. This loads the Bison model. And then let's have Palm. Why did the Scarecrow win an award? Because he was outstanding in his field. I don't know. And lastly, if you have not yet done this, something worth doing someday, is run an LLM locally on your laptop. So Ollama is a software package that's used by many developers to run LLMs locally. So this LLM, I'm running Llama 2 on my laptop. And, why don't scientists trust atoms? Because they make up everything. And I think that it's actually really cool that it's actually, if you haven't done it yet, it's probably much easier than you think to run an LLM on your laptop. You do need a reasonably fast laptop. This is an M2 laptop that I'm running on, but I'll also run it on AMD hardware, run it on NVIDIA hardware. And actually, if you're ever doing demos, if the Wi-Fi is ever down, having a locally running LLM helps a lot. Oh, and actually when I'm on an airplane, when there's a flight here to New Orleans, I was using an LLM on my laptop to get stuff done because I wasn't on Wi-Fi yet. So just one more piece of intuition building. People often think, boy, using an LLM is really expensive, right? So here's a back of the envelope calculation for how much it costs to prompt an LLM. These are some of the prices of different LLMs that I got off the internet. This is a few weeks ago. Maybe it's changed by now. But let me focus on this number, 0.2 cents per 1,000 tokens. And if you were to ask, how long would it take to keep someone occupied for an hour, assuming a reading speed of 250 words per minute and 3/4 word per token? If you do the, back of the envelope calculation, 250 words per minute times 60 minutes. So you need this many words divided by 3/4. So that's the number of tokens times the price of the output tokens. And maybe there's an input prompt as well. So you've assumed the input prompt and the output completion are the same length. And add up these. It turns out that this, back of the envelope calculation suggests maybe it costs you about 7 cents to generate enough text to keep someone busy for an hour. So it's actually remarkably cheap, especially when you use, 3.5 turbo. Some of the other LLMs can be one order of magnitude more expensive. There is maybe 100x difference between the expensive and the cheap LLMs, but I find that many people price optimize prematurely, and it's actually maybe cheaper than you think if you haven't done this a lot yet. And then lastly, with LLMs, there are many text processing applications that used to take me and other teams, 6 months to build, that any of you can now build in very small numbers of hours, maybe tens of minutes or maybe even small numbers of hours. Very common use cases used by many companies, summarizing, given long text, summarize it, inferring, classify text, extract keywords, transform text from one form to another, or to expand text from a small prompt to a very large email. And I want to focus here on, I feel like there's a difference between the web UI, which many consumers use. I do that all the time. So I type in my prompts of web UI versus the practices. So if you're writing a software application by calling an API, a little bit different. But these are common text processing applications, use cases that people are using via the web API. And so let me show you some examples of this. And again, don't worry about the code syntax. It's just to point out how little code it takes. So here's summarizing. Input. Oh, I'm sorry. Thanks, Isa. Oh, could people see my demo just now? Okay, thank you. All right, so here's summarizing. So import some tools from, say again? No. Sorry, couldn't hear you. Ah, got it. All right. So import some tools from OpenAI. There's a helper function. Here's a product review. Got this panda plush toy for my daughter's birthday, so on and so forth. Got to play with myself. And then if you want to summarize it, write a short prompt. You're tasked to generate a short summary product review, F-string, plug in the product review, do that. And then, I just made an API call, and real time just generated this summary, right? And then, you can change the prompt to say, focus on the shipping and delivery. If you want the summary to focus on one aspect. So customers have their price, but suggest, different options. Item appear earlier than expected. So this is one example. Summarizing is a very common use case of these LLMs. Another one is inferring. So let's see. Given a review of a lamp, so this is a product review of a lamp. Need a nice lamp for my bedroom. There are a lot of traditional NLP tasks like sentiment classification. Is this review a positive or a negative sentiment, right? Previously, to do this, we've had to collect training data, run a supervised learning algorithm, find a way to deploy the model on the internet, debug it. But now you can just write a prompt. What is the sentiment of the product review? And then it says, sentiment of the product review is positive. And one common design pattern is, if you don't want it to output a sentence, which may be harder for a downstream piece of software to process, do you want to search your regex to see if it's positive or negative? You can also prompt it to say, give your answer a single word, either positive or negative, and it just says positive. And actually, Isa later will say a lot about how to specify output formats to make it easy to plug in your LLM into one step of your software, so its output can be used in sort of your downstream processing as well. Let's see, one more fun one. Let's see. Transforming text. So, LLMs are actually getting pretty good at translating text. It's actually better for especially high resource languages, I want to say, than some of the dedicated translation websites. Translate the following English text to Spanish. Hola. Sorry, I can't pronounce that. Tell me what language this is. This is French. This is actually translate the following text to French and Spanish and English pirates. I want to order a basketball. I be wanting to order a basketball. It's not bad. But just one fun thing. I find that when I work on translation, because my team members speak different languages, right? I speak English and really poor Chinese. Some of my team members speak Spanish and English. Among my team members, a lot of us, our only common language is English. And so when we're testing translation, English pirate gets used a lot because English pirate is a language we all know. So for some reason among my teams, when we're building translation applications, the first language we translate into is actually English pirate. Let's see. And then just one last example, expanding. So, if you want, there's a product review, and you want to have a short prompt. Your customer review service agent assistant, you're tasked to send an email, right? Given the customer email on top and so on, then this is another use case. You can take a short prompt and have a system generate a longer piece of text for you for sort of communication, right? Don't use this to spam people, but sometimes for legitimate communications, this can be a useful application. All right. So in addition to what I just shared, summarizing, inferring, transforming, expanding, these are operations that you can build very quickly into many applications. And when you're brainstorming applications, these are hopefully useful tools. And then just on top of these things, I think out in the industry, there are two very commonly built applications on top of LLMs. One is retrieval augmented generation applications, where you retrieve a document and have a LLM answer questions against that document. And the other is there are many companies building various flavors of customer service chat and many flavors of chatbots. And let me hand it over to Isa to share more concrete tips on prompting and also to dive more deeply into RAG and chatbots a little bit.
Okay, so in this section, we're going to talk about strategies for getting the best results that you want from language models. The practice of writing and iterating on instructions for a language model is sometimes referred to as prompt engineering. This term was coined to describe the process of prompting base models, so not instruction-tuned models, which it involves kind of more unintuitive tricks, but prompting assistant models is actually very intuitive. So in this section, we'll cover the chat format of assistant models, limitations of current models, and then we'll go into some prompting strategies and tactics for getting the best results from specifically instruction-tuned models. And some of those strategies that we'll discuss will help to address the limitations that we will discuss in the prior section. So this is just kind of reiterating what Andrew said. We're going to first talk about the chat format of assistant models. These are the models that you're most likely to have interacted with in products like ChatGPT, Bing, so on. And as Andrew discussed, base models are trained to predict the next token in a sequence during pre-training. And because of the way they're trained, base models are effectively document generators. So if you start a document, it will just continue returning the most likely next word or phrase because it's just learned from the content on the internet and a few other data sets that it's seen. But we actually want a model that can answer questions and follow instructions. And so we take the base model and teach it to follow instructions in the post-training process, which is, supervised fine-tuning and RLHF, as Andrew discussed. And during post-training, we also use a different data set with examples of multi-turn conversations in a special chat format, where we use special tokens to mark different parts of the conversation. So in the bottom right, there's kind of an example with some special additional tokens, and then the model learns how to use this format. And the examples we use in this process are mostly very high quality examples generated by human contractors and then a few synthetic examples. And the resulting chat models are the models that users now interact with, as I mentioned. And so instead of taking in just a prompt and giving a completion, these models use a different format. And the input is actually a list of messages. And then the kind of response will be an assistant message. So each message has a role, which is one of system, user, assistant, or tool, and content, which is just the content of the message. And in general, these messages are formatted with a system message first, followed by kind of alternating user and assistant messages. And the system message acts as a kind of high-level instruction that sets the behavior or persona of the assistant. And you can kind of think of it as whispering in the assistant's ear, guiding its responses without the user being aware of the instruction. So it's a good way to frame the conversation without making the request itself part of the conversation for the user. And then the user entries are just, the user input, and then the assistant messages are the completions. And then the final type is tool. We'll talk about this more later, but we can augment the abilities of models by giving them access to tools like internet search or the ability to run code or call specific functions. And so tool messages are just a type that we have for kind of the output from these tools. And so although the chat format is designed to make multi-turn conversations easy, they're also useful for just single-turn tasks without any conversation, where you put the prompt instructions in the system or in the first user message and or the system message, and then you get the response in the assistant message. So I'll show you a few examples of this format. This is the playground. It's just a UI we have for interacting with language models. So in this example, I've put the instructions, you're an assistant who responds only with words beginning with S in the system message. So that's the high level instruction. And then I'll say something like, tell me a joke about an AI conference. So here we have our joke. And since we're having a conversation, I can kind of ask in a follow-up message, say I want this to be shorter. I can continue to refine kind of what I'm asking for. And so this is a multi-turn conversation. You can also, instead of having kind of this conversation, I could have put more instructions in the original system message. So I could say, make sure your response is only a few words long. And then in this case, the behavior of the assistant is as we instructed. So that was an example of a back and forth conversation, but you can also, as I mentioned, use a model to complete an individual task where you define the task in the system message and then you put the actual input that you want, the input of the task in the first user message. So I'll show you another example. So this is a slightly longer example. Basically, the task is to distinguish between promotional emails and personal communications. And we're saying your primary focus is to ensure that emails from actual people are not ignored. And then we're asking the model to respond with just the word true or false, depending on if this email is kind of promotional or not. And then I just have a random promotional email that I received using this format that I specified. So if I run this, it's true because this is a promotional email. But then in the instruction we said, your primary focus is to ensure that emails from actual people are not ignored. So if I add kind of an additional paragraph to the email, just pretending that this is from Evan from West Elm, San Francisco. And then you see in this case, the model knows that this is from a real person and we don't want to ignore those emails. So that was just an example of using the system message to define the task and then the first user message for the actual input for the task. Great. So that was the chat format of assistant models. Next, let's discuss some of the limitations of current models. So even though language models haven't been exposed to a vast amount of knowledge during their training process, they haven't perfectly memorized all of the information that they've seen. And so they don't always have a good sense of what they know and what they don't know. And this means that they might try to answer questions about obscure topics and can make things up that sound plausible but are not actually true. And we call these fabricated ideas hallucinations. And in some ways, you can kind of think of anything a model outputs as a hallucination in that it's coming up with its best guess for text to produce based on what it's learned from all the data it was trained on. And I actually think that the issue with hallucinations at the moment is that while in some contexts it's okay to hallucinate, for example, if you're asking for help with creative writing or new creative ways to address a problem, in other cases it isn't. So in cases where you want factual information or formal output or something, and the current models aren't always very good at differentiating between these situations. And so we probably don't want models that never hallucinate because you can kind of think of it as the models being creative, but we just want models that hallucinate in the right context. And over time, we'll continue to decrease the likelihood of hallucinations from language models in factual contexts. For example, GPT-4 at time of release scored 40% higher than GPT 3.5 on internal factuality evals. And there's an example of a hallucination on the slide. So it's just asking about a fake product from a real toothbrush company. And you can imagine a situation where if you were brainstorming products, you might actually want the model to output something like this. But if you're asking what is, you're most likely looking for factual information. And so it's probably not the right time for a hallucination. Other limitations, models have limited context windows. So the number of words you can put into a prompt. and they don't learn about you over time. They don't have memory, so they don't get to know your use case as you continue to use them. There's also a knowledge cutoff for kind of the end of the model's training data. And then also there are just some tasks that are too hard for the model. With some simple math, we can address the math reasoning abilities by allowing the model to execute code, but there are some questions that are just too challenging. So now let's move on to some strategies and tactics for getting better results from models. We're going to discuss 3 different strategies and then some tactics within each strategy. These are write clear and specific instructions, give the model time to think, and use external tools. And this whole section is about prompting language models in the context of using them to build your own applications. However, most of these techniques could also be used or adapted if you're interacting with a language model as a consumer, for example, in ChatGPT, Bard, Claude, Bing, or something else. But if you're interacting with a model in a conversation, you don't need to be as careful with your first prompt because you can always refine and iterate what you're asking for throughout the conversation. But if you're building an application that uses a model to complete a task as part of a workflow, for example, you'll want to make sure that you're consistently getting results you want from different inputs in the format you want. So that's where you really want to make sure that your initial instruction is good. And in general, I would recommend starting by writing a prompt that works well for a more advanced language model. And then once you have something you're happy with, you can try adapting the prompt to work with a less advanced model, maybe try and make the prompt shorter so you can save how much you spend on tokens. And throughout, I'll be using GPT-4 and GPT-3 for examples, but these strategies and tactics should apply to other language models as well. And there's a few examples linked on the slide, so we'll figure out a way to share them after so that you can look at them as well. So the first strategy is write clear and specific instructions. This might seem like a very obvious point, but models can't read your mind. So you should always express what you want the model to do in full detail in the same way you would if describing a task to another person who is very smart, but who has no prior context or knowledge of your specific task. If you reduce ambiguity or possible interpretations of your request, then you'll reduce the chances of receiving irrelevant or incorrect responses. And you shouldn't confuse writing a clear prompt with writing a short prompt, because in many cases, longer prompts actually provide more clarity and context for the model, which will lead to more detailed and relevant outputs. So first tactic is give detailed context for the problem. And so one method is to just make sure you include details in your query to get more relevant answers. So there are a few examples on the slide. Instead of saying, how do I add numbers in Excel, say, be very specific about the context in which we're trying to add numbers. So how do I add up a row of dollar amounts in Excel? I want to do this automatically for a whole sheet of rows, and so on. The next method is to instruct the model to answer using a reference text. As we discussed, the models can very confidently invent fake answers. And in the same way that a cheat sheet can help a student in a test, or if you were doing a reading comprehension, you would need to have the article in front of you instead of trying to answer from memory. Providing reference text to models can really help get more relevant answers that contain fewer hallucinations. This also, given that the models have limited context windows, we sometimes need to have a way to dynamically look up information relevant to a task. And you can do this with embedding retrieval, which we'll talk more about in the external tools section. The next method is to use delimiters to clearly indicate distinct parts of the input. And you can use triple quotes, triple backticks, XML tags, anything really, just to clearly separate specific pieces of text from the rest of the prompt. I like using the 4 pound signs or triple quotes, triple backticks. A lot of them are 1 token, which is nice. The examples on the slides are fairly simple, so it probably won't make a huge difference if you include delimiters, but the kind of more complicated the task, the more important it is to be very clear about the different sections. And in my personal use, whenever I'm asking for debugging help, if I have to input a bunch of different files, I'll always use delimiters to let the model know, where the different files end. So the next tactic is to specify the desired output format. So one thing that you may have seen is people asking the model to adopt a persona. Sometimes you can say you're an expert engineer or copywriter. If you're building a chat application, you might want to describe the persona that you actually want the model to take, like a pirate, or to, respond in the style of Shakespeare. The next method is to specify the desired length of the output. So you could ask the model to produce a target length of sentences, paragraphs, bullet points. The models are not very reliable at generating a specific number of words because of the way that words are split into tokens. The next method is to ask for output in a specific structured format. The models are very good at outputting structured data if you give them a detailed description of the format that you want. So I'll show you an example. So in this case, we're asking the model we're going to give it a section from a research paper delimited with 4 pound signs. And the model's task is to extract the title, authors, and date. And it must output a JSON with a title, authors, and date. And then if you can't find one of the fields, just set it to a default value, so an empty string or an empty list. And then I've just copied the first page from the Instruct GPT paper. And so as you can see, we get this structured JSON output, and I don't think the date was included, so it set the date just to an empty string. So this is a nice way to get kind of structured data from unstructured text. The next method is to provide examples. So in general, it's better it's more efficient to kind of just explain what you want the model to do rather than demonstrating by example. But there are some cases where providing examples might be easier. For example, if you want the model to copy a particular style of responding to user queries that's hard to explain, this might be a helpful method. This is known as few-shot prompting, although that term really is more used when describing prompting-based models, because you need to kind of trick the model into responding in the format that you want by giving it a few examples, but we can still kind of use the term. And so in this example, we have an example and then another query from the user. So the system message is to answer in a consistent style, make sure to use consistent length, punctuation, and phrasing. And then we have an example of this assistant response with this like very specific punctuation and kind of using metaphorical descriptions. So if we ask the model to describe the ocean, it kind of responds in a very similar response with a similar length. So in some cases, this might actually mean that you can have maybe it will be fewer tokens to just have a short system message and then an example. So the second strategy is give the model time to think. So if a person was asked to multiply 39 by 27, they probably wouldn't know the answer instantly, but could work it out with time. And in the same way, models make more reasoning errors when trying to answer right away rather than taking time to work out an answer. And so if a model's making a reasoning error by rushing to an incorrect solution, you should try to reframe the question to request a chain of relevant reasoning before the model provides a final answer. And asking for a chain of thought is sometimes known as, before an answer can help the model reason its way towards correct answers more reliably. And you can kind of think of this as asking the model to think longer about a problem and make incremental progress, spend more computational effort on the task. So the first tactic is to guide the model's reasoning with steps. The one method is to just specify the steps required to complete a task. Sometimes, some tasks are best specified as a sequence of steps, and so writing them out explicitly can sometimes help. In the example on the right, we're asking first for a summary of some text and then a translation. For advanced models, it would probably be able to do this already, but if, accuracy is really important to your application, and maybe this would increase the accuracy of getting a good summarized French translation by a few %, it might be worth kind of breaking it down into steps. The next method is to instruct the model to work out its own solution before rushing to a conclusion. So for example, suppose we want the model to evaluate a student's solution for a math problem. The most obvious approach would just be to ask the model if a student's solution is correct. So in this case, we have a math problem and then a student solution. And then our system message is just to determine if the student's solution is correct or not. And so GPT-4 says the student's solution is correct. However, this is actually an incorrect answer because in this part, I think X is the number of square feet and the maintenance cost is actually 100,000 plus 10X instead of 100X. So what we can do instead is in the system message, ask the model to first work out its own solution to the problem and then compare its solution to the student's solution and evaluate if the student's solution is correct or not. And then we say, just to reiterate, don't decide if the student's solution is correct until you've done the problem yourself. So first, the model works out its own solution, figures out the answer is actually 360x plus 100,000, and then is able to conclude that the student's solution is incorrect. This next method is very similar to the previous one, but in some applications, the reasoning process that a model uses to arrive at an answer you might not want to share it with the user. For example, if we were building a tutoring application, if we just showed the entire model output, it would kind of give away the question, the answer to the student. So in a monologue is a way you can mitigate this by basically asking the model to put parts of the output that are meant to be hidden into a structured format that makes parsing it out after more simple. So, sorry, this is a bit of a long system message, but we're basically asking the same steps as we did in the previous example. So first work out the problem, then compare your solution to the student's solution. And then if they made a mistake, determine what hint you would give them. And then step forward, just output the hint. So the model then separates the parts of its response with these triple quotes. And then you can imagine if you were doing this from code, you could just find like the last occurrence of triple quotes or something to get the hint. And then so I guess that's a pretty explicit hint, but we did get a hint. Sometimes a hint is less explicit. So our next tactic is to use a model to iterate on its own work. Sometimes models miss things on their first attempt, especially if you really fill their context. For example, if you asked it to extract quotes from a long document, it might stop early and fail to list all relevant excerpts. So in that case, you can sometimes get better performance by prompting the model to with follow-up queries to find additional excerpts. You need to be careful not to kind of ask leading questions because the model is eager to please, so it might just find more quotes even if they aren't really relevant. And in addition, the current models are not very good at self-reflection during inference, while they're making a completion, because they're trained to predict the next most likely token, even if they're on kind of starting down an incorrect path while generating an answer, they'll just continue down that path, choosing the next most likely token. But if you ask the model in a subsequent call to check its own work, it would be better at kind of evaluating its previous message. Another thing you could do is ask the model to answer a question multiple times and determine the best answer. So if you're building an application where accuracy is the most important thing, maybe at the expense of latency or cost, you could generate multiple model responses with either different prompts or different temperatures, which is just the degree of randomness of the model's response. And if, say, the answer was objective, like a number or a string or something, you could just take the most frequent answer from the different completions. And otherwise, you could also use another prompt to choose the best answers based on all of the different model-generated responses. The next tactic is to break complex tasks into simpler subtasks. So, just as you would decompose a complex system into modular components while writing code, the same thing can be true of tasks for language models. And sometimes complex tasks have higher error rates than simple tasks. And sometimes you can redefine a very complex task into a workflow of more simple tasks. And then based on the output of the previous task, take a different next prompt. So the first method is to use intent classification to identify, now I'm reading this is very wordy, to identify the most relevant instructions for a user query. And so in the example, we have a kind of customer service assistant, and you could take a first step where you take the query and you classify it into a category. You could ask for like a structured output with a primary category and a secondary category, for example. And then once you have the output from the first prompt, you can take, say it was, the user query was classified as technical support. You could take different instructions based on the result at that step. And the advantage is that this can also lower costs because you don't need to have very large prompts at every single step. The next method is to process long documents piecewise and construct a full summary recursively. So since models have a fixed context length, you can't always summarize a very long article. So what you could do is break a longer article into smaller chunks and then do a task on each chunk, and then at the end combine them or use another call to the model to combine them for you. The final strategy is to use external tools. So you can augment the capabilities and also compensate for weaknesses of models by feeding in the outputs of other tools. So for example, you can give the model access to real-time information since it's knowledge cutoff via APIs or internet access. You can improve the model's math ability by allowing it to use a calculator or execute code that it writes. And you can also address the context limit by intelligently retrieving information when needed instead of trying to fit as much as you can into the context. The models themselves are actually also very good at figuring out when to use tools if they're given access to them, which we'll talk about as well. So I think a general rule of thumb is that if a task can be done more reliably or efficiently by a tool rather than by a language model, you should offload that task to get the best of both. So we'll talk about retrieval, code execution, and function calling. So the first tactic is to use embeddings-based search to implement efficient knowledge retrieval. So as we've said, you should include relevant context in your in your prompts. So in the example on the slide, if you asked a question specific to your own documentation, for example, a normal chatbot or chat model wouldn't know the answer, but if you put relevant information into the context, it might be able to answer the question. So how do you get that information? You can basically use this strategy to find the information that you need when a user asks a question from a document and then insert it into the prompt. And so one way to do this is using text embeddings. So many of you, I'm sure, know this already, but an embedding is a numerical representation of a string as a vector, and similar or relevant strings will be closer together than unrelated strings. That's kind of the picture on the right. And so this, along with the existence of very fast vector search algorithms, means that we can use embeddings to retrieve relevant information from a very large corpus of text. So the way that this works, sorry, this is a bit of a busy slide, but what we can do is take a long document or long documents and split them up into smaller pieces. And then for every single document chunk, you can create an embedding of that chunk. And then you can store those embeddings in a vector database. There are many different vector databases you can use. And they just have very kind of optimized similarity search algorithms. And then when a user makes a query, so in this example, is there parking for employees? What you would do is also create an embedding for the query, then do a similarity search between the query and all of the document chunks you have stored in your vector database. And then you would take the most relevant document chunks and then put those into the prompt that you use for the model, because we're assuming that those are the chunks that contain relevant information to the user query. There are lots of different things you can do with this. You can get really fancy and do overlapping document chunks. You can experiment with different lengths of chunks. You can even do, small, really large chunks and then kind of do a subsequent search to find like more granular results from smaller chunks. And I also want to note that you don't need to use embedding search. Embedding is just a nice way to kind of make a lot of unstructured text searchable pretty easily, but you could use keyword search. You can use a combination of keyword and embedding search. It's just about getting the right information into the model's context at query time. And I've linked a GitHub that has that lists a few vector databases that you could try. The next tactic is to use code execution to perform more accurate calculations or call external APIs. So language models can't really be relied on at the moment to perform arithmetic or do long calculations accurately by themselves, but they're very good at writing code. So in some cases, you can ask the model to write code and then execute that code. And then you can give the output of the code back to the model and it can figure out what to do with it. I want to give a disclaimer that executing code produced by a model is not inherently safe, so you should be careful and potentially use a sandbox code environment so nothing bad happens on your computer. And the final tactic is to give the model access to specific functions. So as we've seen, models are very good at generating structured output. And so if you give them a list of function descriptions as instructions, they can generate function arguments according to the provided schemas and write calls to them when appropriate. And you can then implement those functions on your end using the parameters the model decides to use. For example, you could call an external API, and you could either just do that, or you could give the function response back to the model, and then it can continue reasoning about it. So some examples of things you could do: you could convert natural language into API calls. You could, extract structured data from text. We've kind of already seen a few examples of that. And yeah, OpenAI API natively supports function calling, so recommend checking that out as well. And so here's an example of a simple weather function. So we have the name of the function, the different parameters and descriptions of the parameters. So just to summarize this section, we've talked about the chat format of assistant models with system, user, and assistant and tool messages. We talked a bit about model limitations, hallucinations, limited context window, knowledge cutoff, and advanced reasoning. And then we've talked about some prompting strategies and tactics, which were write clear and specific instructions, give the model time to think, and use external tools. And you can find more example prompts in these two resources I linked, the OpenAI cookbook and then this prompting guide. And yeah, all of the methods we just described can be deployed in combination for greater effect. You may have noticed in some of the prompts that we were using kind of many of the different methods. So I encourage you to experiment with them and find the methods that work best for you. Okay, so next I'll show you an example application, because we just talked about how we can improve language model performance by giving them access to tools like retrieval, code execution, and function calling. But the models themselves are very good at deciding when to invoke these tools, how to interpret the output, and then if they should make any additional calls. For example, if there's an error message from code execution, they can figure out what the error was and kind of improve the code and then re-execute it. I think for a lot of retrieval applications, people will just explicitly at every single message try and fetch relevant context, but you could also instead allow the model to write queries itself. There's benefits to both. So we're going to go through an example application that will use all of the tools that we just discussed. And for the example, we're going to use the OpenAI Assistance API. I think just stepping back for a second, over time, we'll continue to augment models with tools and access to real-time information about the world, and we'll give them more and more agency to complete tasks that require a series of actions that they can decide on themselves, and both synchronously or asynchronously in the background. Right now, most things we do with kind of models is quite synchronous, but you can imagine like coming back to your favorite language model and it's like done some processing in the background for you. And so the Assistance API is just the beginning of this kind of future of more autonomous AI agents. And they're able to leverage tools, all three of the tools, and you don't actually have to set these tools up yourself. You can just kind of use them out of the box with the API. And so the three tools that we're going to use are retrieval, code interpreter, and function calling. You could implement all of these yourself, especially if you really need granular control over your retrieval system, for example. But some things are harder to build yourself, like code execution. So if that's you, you might want to try this. Okay, here we go. So this is another view of the OpenAI playground, but for assistants. So in this example, we've created a NeurIPS helper. So we have our instructions. This is basically our system message. So we're telling the NeurIPS assistant a little bit about itself. We've given details about the venue, a little bit of we've given it access to some conference information. So I've just added a description of some things it has access to. And then it also has the ability to get the current weather and get directions. And so we've given it access to two functions. The first one is get weather. So it just determines the weather in a certain location and has these different parameters. And then also get directions, which is pretty similar. And then we've enabled code interpreter, which will allow the model to write and execute code, and then also retrieval. And this is just a document where I copied a bunch of information from the NeurIPS website into a long document. And then when the assistant is created, what happens on the back end is we take this document, split it up into smaller pieces, create an embedding for each of those smaller pieces, store it in a vector database. And then when we ask questions that the model thinks there could be some relevant context in the document, it will query the kind of knowledge base to see if there's anything. So I'll ask a few questions. So I'm going to say, I went to a talk on AI in drug development yesterday. Could you remind me the name of the speaker? So what's happening now is the model's going to write a query to the knowledge base to find the relevant information. And so here we have the name of the speaker from the expo yesterday. I'll ask another question. So where can I get food on Tuesday? This will also hopefully trigger retrieval. Even though the model has access to many different tools, it's able to figure out which one it should use depending on the user query. So now it's issuing another query to the knowledge base to try and find any relevant information about this question. So here's information about where we can get food tomorrow. Okay, my next question is going to be, what will the weather be like on Wednesday? I want to go on a run and end at Jackson Square. How can I get back from there to the conference center? So hopefully now the model will know that it has access to these two functions and that it might be a good time to call them. And the model's actually able to do parallel function calling, so it can call use multiple tools at the same time. And then if we were actually building this application, this is a point at which in your code, if you see that there's a function call in the assistant message, you would actually call the function and then return the output in the next message. In this example, I'm just going to type in the response. And so now the model can use the responses from the function calls in its next answer. And then I'll finally show you code execution. So say I just had a team lunch with 8 of my coworkers, and it was 270.21. How much do we each owe? So the model is writing code for code execution. And we can check its reasoning. I think it actually made a mistake because the number of people should be 9. Usually it gets it right, so I'm live demo. Okay. Let's see. Oh, it's failing me. really want this to work. But plus me. Okay, well, that's why we're not going to be replaced by AI yet. Okay, that was the assistance demo. Okay, before I hand it back to Andrew, I'm just going to talk a bit more about other tools you can use for building AI applications. So in this section, I'll talk a little bit about multimodal models, moderation, and prompt injections, and then Andrew will talk about fine-tuning and some other topics. So firstly, multimodal models. Right now, models usually take in a few modalities and then output one or two modalities. But in the future, we'll have models that are able to understand many different modalities and also output many different modalities. I think Gemini is already able to do something like this. Other tools you can use are vision models like GPT-4V, Gemini, speech-to-text models, text-to-speech models, text-to-image models, and large vision models. Right now, you have to kind of chain calls to different models together. If you want to create a multimodal experience, for example, ChatGPT voice would use, speech to text, text to text, text to speech. In future, we should have models that are just able to do the whole thing. Next, we have moderation. If you're building a system where users can input information, it's important to first check that they're not trying to abuse the system in some way. So one tool you could use is the OpenAI's moderation API, which basically identifies and filters prohibited content and classifies it into categories and subcategories. And it's free to use if you ever want to use it to monitor inputs and outputs from OpenAI models. And then finally, I'll talk a bit about prompt injections, which is in the context of building a system with a language model. This is when a user attempts to manipulate the AI system by providing input that tries to override or bypass the intended instructions or constraints set by the developer. So for example, if you're building a customer service bot designed to answer product-related questions, a user might try to inject a prompt that asks a bot to do their homework or generate a fake news article. But prompt injections can lead to unintended use of your AI system, so it can be important to detect and prevent them to ensure responsible and cost-effective applications. So two strategies you can use to try and identify them. First, using delimiters to mark user input can help. And then in the system message say that the user input will be between the delimiters. Another is to, if this is really important to your application, you could use an additional prompt to try and spot a prompt injection, to kind of classify it as a prompt injection or not. There are also much more advanced types of prompt injections where, researchers have found, example strings when appended to a message will make them kind of act as a jailbreak for the model. Or, if you ask a question in a different language or encoding, sometimes it will circumvent the safety measures put in place. Another thing is kind of just manipulating the model by pretending to, you can say, you're acting as my grandma who told me stories about so-and-so. And you can sometimes circumvent safety policies as well. And security of these models is a very active area of research and is not a solved problem. So I'm sure people will continue to find jailbreaks, and then AI companies will continue to try and fix them. So with that, I'll pass back to Andrew to talk about fine-tuning.
Which is a trend toward thinking about an LLM as a reasoning engine rather than just as a knowledge store. So what I mean is, LLMs, having pre-trained on tons of text off the internet and elsewhere, have a lot of general knowledge, but they don't know everything, such as access your proprietary information. And it tends to know the kind of common facts, like what is value of gravity, things like that. It knows really well, but the niche long tail facts is actually more likely to hallucinate on as well. But, oh yeah, thanks for reminding me. Awesome. Thank you. But there's a way of thinking about LLMs I think is very powerful, which is to think about providing relevant context in the prompt and then using the LLM to process information to get the answer that you want. And as part of processing information, it can also choose to call tools, such as call a tool to retrieve a piece of information or check what is the weather, or find directions from A to B, some of the easiest examples. And I think this is a different way of thinking about LLMs. You may be used to going to ChatGPT or Bard and asking a question and using it as a knowledge store. But it turns out LLMs, they're okay. Well, maybe that's surprisingly good as a knowledge source. It's memorized a lot of facts, but this other paradigm of using it as a reasoning engine, I think opens up, an even larger set of exciting applications, such as the agents, applications that Isa was chatting about. In the presentations that, you've heard Isa and me give, we've gone over a lot of different tools for building with, LLMs. I just want to cover one more tool really quickly, which is fine tuning. And this relates to taking a pre-trained LLM and then training it a little bit longer on data of your own. So one application of this would be if you want to change the tone of an LLM output, tone or style, particularly in cases where it can be hard to specify the desired output in a prompt. So, for example, if you prompt an LLM to summarize customer calls in a certain style, within fine-tuning, maybe you get a generic thing like this. I actually got this example inspired by some work that the AWS folks did. But if you fine tune it, you can create examples of how the style of summary you want to be more technical, more specific, and fine tune it to try to get its output, summaries in a certain style. Although before going to the complexity of fine tuning, I would try really hard to prompt it first. And only if you really can't get it to work using prompting, then maybe go to complexity of fine tuning. And fine tuning also works with probably fewer examples than most people think, with, couple hundred documents of maybe 100 words per document, maybe more. Maybe that's kind of the lower end, but it probably starts to work with less data than most people think. One more fun example. One of my team members, Tommy Nelson, decided that he was trying to get, LLM to sound like me. And after lots of work prompting an LLM, to sound like me, it just didn't sound that much like me. But I guess in his ongoing attempt to replace me or something, I don't know what Tommy's trying to do, he took a lot of my transcripts, stuff that I had said, and fine-tuned an LLM to make it sound more like me. And it turns out that when Tommy took metrics of the way I talk, I actually often start off sentences with the word so, and taking metrics like that, it really does seem to sound much more like me. And let's see, just for fun, I'm going to use Olama to run so we call the model DLS-ANG, DLS Andrew. So we'll load it, and then here's the instruction history. Write a short script in the voice of Andrew for a video, call best practice prompt engineering with an LLM API, blah, blah, blah. And this is generating in real time, on my laptop, right? So, and again, I know this is a lot of text, but according to various metrics that, he ran, here, let me hit Control C on this. Let's see, where's my mouse? Great. Welcome back to our course on generative AI. In this video, we're going to talk about best practices for prompt engineering. That does sound kind of like me. Let's run again. Yeah. And I think, this isn't using any, there's no RAG in this particular example. Oh yeah, there it goes. There's this. So it'll be important to include some information. And when we took metrics like average sentence length, frequency with which a sentence starts with so, by those metrics, it does sound more like me than anything Tommy was able to prompt, GPT-4, to build output. And I will let you know when I lose my job to this. And just one important caveat, probably more people use fine-tuning. I do see many teams using fine-tuning and using it well, and it's a very important tool in the developer toolbox, but probably more people are using fine-tuning than is strictly necessary, because it is much more work than prompt engineering or just using something like RAG. If you want your LM to have, certain body of information, try RAG first. And maybe rule of thumb, I think fine-tuning is probably somewhere between 10 to 100x more work, right, than fine-tuning or using RAG or tools like that. So try those options first, and only if you're sure you want to fine-tune, then go for it. And then it can be very powerful as well. All right. Now, last thing I want to cover is I want to share with you some practical tips for building applications. And I really hope that, if you aren't already, hopefully many of you already are, but if you aren't already, after NeurIPS, go home and go build some stuff, because there's so much cool stuff you can now build so much more easily than ever before. And I want to start off, discussing one way to identify project opportunities that my team and other teams have found useful. So you're wondering, what should I work on? If you and your friends brainstorm something, great, go for it. Try it out, do it in a safe and responsible way, but still try stuff out and learn from it. And there's actually one recipe that my teams have executed with quite a few large corporations that every single time we end up with good ideas for automation using AI, which is a lot of people talk about AI automating jobs. But it turns out that a more useful framework to think about AI is as automating tasks rather than jobs. And most jobs involve a collection of many different tasks. And so, what I've done multiple times in multiple businesses, talk to companies that may have 10,000, 100,000 employees and will ask, what are all these people actually doing? So for example, customer service representative may do a set of tasks like answer inbound phone calls or answer customer chat queries in text or check status of customer orders and on and on and on. And what we would do is systematically figure out of all of these people, what are the tasks they're doing? And then for each of the tasks, evaluate it for AI potential, automation or augmentation potential, according to both technical feasibility as well as, value to the business, how useful it is. And often you end up with some ideas that are high potential for AI augmentation, where you're helping a person, or automation who can fully automate the task. And a lot of the analysis for task-based analysis of jobs was developed by some of my friends, Eric Bernofson, Tom Mitchell, and Daniel Rock. A really nice paper. And it turns out that there are websites. ONET is a US government-funded website, and there are others outside the US as well. But ONET is a little bit US-centric. There's some others that are a little bit more international that take jobs and break them down into tasks. And I find that ONET Online is what a lot of economists use. Is kind of list some of the tasks of a customer service representative. When I use these websites, I find that the descriptions are always a little bit fuzzy and not quite right. They're maybe like, they take you 70% of the way there. But what I actually end up doing is when I look at a company, we actually look at what the people are actually doing rather than what ONET or a website says, since ONET tends to have more generic answers. And just to walk through some of their examples, computer programmers, this is not the most careful analysis, so don't take the details too seriously. But when we think about how can AI help with a certain person's job, there's often that picture we have in our heads of what a job entails, right? What do computer programmers do? Well, we write code. That's just a stereotype of what computer programmers do. But when you analyze what most roles do, they're actually much longer list of tasks than the most obvious one that tends to pop into people's minds. And for example, we also spend a lot of time writing documentation. And maybe that's actually easier to automate or augment, than writing code. And I've seen a lot of examples where, and maybe one other example, radiologists, what do radiologists do? On mental pictures, they read x-rays, and that's true. But they also do a lot of other tasks like gather patient histories, or, mentor younger doctors or whatever. But it turns out that patient intake may be easier than even reading x-rays. And it's often not that first picture that pops in your head that's actually the best automation opportunity. And here's another one. What do lawyers do? Our mental picture from TV is lawyers stand in court and argue cases, right? But it turns out that if you actually analyze what lawyers do, there's a lot of drafting and reviewing legal documentation that is more easy to augment or automate using AI than, representing clients in court, right? Which seems harder at this point in time, I think. So I find that the systematic analysis, I think every single time I've done this with a company, we wound up with, exciting ideas, that can then be either build or buy decision. You don't need to build everything from scratch. Sometimes there's a tool that you can just buy as well, but sometimes there are unique things we end up building. And then our focus on analyzing the tasks done by people, employees of a company. The other recipe is to look at what the customers of a company do. So if you run a website that helps people build web pages, then think through, what does building a web page do, since that's a job of your customer rather than a job of your employee, and identify tasks there. And this often creates exciting ideas as well. So hopefully with this type of analysis recipe, it can help you generate even more ideas than the typical brainstorming. And it turns out that sometimes people wonder, if you use this recipe, look what tasks people do, automate or augment some of them, this only leads to cost savings, right? It turns out that's not true. So let me tell you, let me share with you some of the things I see in terms of how the workflow ends up being redesigned when we have machine learning or LLMs or something to automate or augment some tasks. So this is just a example of illustration. If a surgeon without Gen AI tools carries out surgery, maybe they spend a long time researching the details of medical procedure, then they carry out the surgery, right? And the length of these bars is intended to indicate the hypothetical length of time spent on this. And you may decide that with an LM or maybe a QA rack system or something, maybe we can shorten the time needed to do research on the medical procedure, for the prep, but carrying out the surgery still takes a similar amount of time, right? So you can see the value creation. There's now maybe less work for a surgeon. This is a hypothetical example, right? But it turns out that rather than cost savings, which this example illustrates, this recipe that I just described, I'm also seeing it frequently lead to ideas, not just for cost savings, but for growth. So for example, let's say a marketer spends a lot of time writing website copy, and then they push the copy to a website. With automation, let's say, writing the website copy is now much shorter effort needed, and maybe put in some automation tools to make it easier to push the website. So one thing you could do is take the cost savings and just, be happy with that. Nothing wrong with that. But when you make something 10 times or 100 times cheaper, other than just taking the cost savings, the other thing you could do is do that task 10 times more. So for example, in this case, now that writing copy and pushing the website is so cheap, you could write copy, push the website, write copy, push your website, launch your A/B tests, analyze the campaign performance, improve prompts. And so this would be an example of when one task becomes cheaper, you can now do that task 10 times rather than once. And this creates new workflows that lead to, growth and not just cost savings. And so this is exciting as well. So hopefully this will, maybe this will help you have a systematic way to go back to your teams and find things to do. And it's actually an interesting exercise as well to sit down and look at, your own workflow. I sometimes look at, all right, what am I doing today and what can I automate in my own job? It turns out my job's really hard to automate, which is kind of a bummer, but I'm trying. Now, last thing I want to do is step through with you the workflow of developing an LLM-based application. Let me share with you kind of what it feels like to build these applications. And one exciting thing about building applications with LLMs is you can build prototypes really quickly. So with supervised learning, this is what, my teams and I used to do. We get label data, train an AI model, find a cloud service to deploy it, and then it takes us 6 to 12 months to deploy a production grade machine learning model. This is what we used to do. And in case 6 to 12 months seems long to you, yes, I know you can hack something up in your Jupyter notebook over a weekend, maybe even less than a weekend, but this is really a realistic timeline if you talk to people in large enterprises for building a robust production grade reliable machine learning system. I mean, this is really how long it takes. If you don't believe me, ask the people working in big corporations. I mean, to make it good, this is really a realistic timeline, sometimes. But with LLM-based development, you saw, Easier and me both throw up things really quickly, right? Specify a prompt that takes minutes or hours, and then using the cloud APIs in hours or maybe days, you can be running, you can have a prototype up and running. And this is very exciting because it lets you test and fail things much more quickly. In fact, one design pattern I'm seeing is that given that prototyping is so easy, consider quickly implementing lots of features or lots of prototypes and then evaluating them to see what works, right? So if it takes you 6 months to build something, then better do careful user studies, have product managers, make sure it's really valuable. Then you build it, then you ship it. And boy, let's hope that 6 months of investment pays off, right? That's what many of us used to do. But when you can throw together a prototype, in an afternoon, well, just go do that, or even throw together 10 different prototypes and then, go and see what sticks. With one important caveat, which is do take responsible AI seriously. Don't throw stuff out the door that could cause harm. If there's a risk of harm, collect the test set, measure, audit it, make sure you don't have a harmful impact. But I see a lot of applications where I can't think of any where diverse team brainstorms that we think is responsible to just try it out or do internal prototyping and internal testing. And this is a very rapid way to just test out lots of ideas and then see what actually works. And when you're developing an application, this is what it feels like. You can often build an initial prototype using an API. And so, my team at AI Fund, Carlos Alzate, and Hernan, who are somewhere at NeurIPS, I think, we routinely build applications using large language models and Streamlit in hours. Actually, I don't want to advertise tools, but Streamlit is really one of my favorite prototyping tools. So here's an example. Streamlit. Let's see. So having used Streamlit before, this is an example of a Streamlit app. I think I threw this together 1 or 2 months ago when I was sitting in a coffee shop. It probably took me like 15, 20 minutes to build this. I don't know how to print. Hello. And, I wanted to, maybe simultaneously annoy my friends in multiple companies to throw together a Streamlit app to take my prompts and send it to multiple APIs. And it took me probably, 15, 20 minutes to write this. Oh, and it turns out GPT-4 is pretty good at writing Streamlit code. So I would say GPT-4 wrote half the code and I wrote half the code, but it's really quick to build prototypes like these days. And then, assuming it's safe, again, taking responsible AI seriously, if there isn't risk of harm, then take a Streamlit app, deploy it to internal testing or even external usage, and see how it performs. And you start getting user feedback really quickly. Now, compared to older machine learning workflows, one weird thing about this workflow is there's no test set, right? Because in a traditional machine learning workflow, I might collect 1,000 training examples, and if I'm collecting 1,000 training examples, then I'm fine collecting another 100 examples for my, holdout development set or my test set, right? It's like, we need to collect 1,000 examples, I'll save 10% of it for testing. But when you're just writing a prompt, I can write a prompt in like 5 minutes or 1 minute. So it's really painful if I need to go and collect a separate 100 test examples. Right. So in this new LLM workflow, we often build things that even kind of starts to work without a test set. And this is why a lot of people talk about evaluation of these models, because unlike the traditional machine learning workflow where you have a training set and a test set, now I don't want to slow down. If it takes me half an hour to build this, well, I don't always want to go and spend a week collecting my test set unless there's a responsible AI component that means I have to test it and audit it more rigorously. But if it's safe application, then the workflow is just build it, test it, or ship it, see what happens. And then again, I know what I'm saying may be sacrilege to a lot of, traditional ways we think of machine learning, but what teams often do is monitor the performance. And then when we spot an error, like summarize this text, whenever it makes a mistake or see as a tricky example, we then tend to take the example that it makes a mistake on and stick that into hand-curated evaluation set. So there's nothing IID, right? This is not an IID test set. It's like, made a mistake. I'm going to handpick this error and put this handpicked error into my evaluation set. And then when you're further tuning the system, Isa mentioned for RAG, there are tons of hyperparameters. How long, when you chop up a document to throw into a vector database and embedding, what's the size of the chunk? Many hyperparameters. How many articles do you retrieve? What's the details of prompt? So when tuning those things, we'll often, change the system and then kind of eyeball how well it does on our small hand curated evaluation set. And sometimes doing this is good enough to build and ship a, valuable system. But to go up to further levels of rigor, if your test set gets big enough, it's then useful instead of trying to eyeball, look at every time you change something, you have to read 10 outputs. And eventually every time you change something, you have to read 20 outputs. It starts to get annoying after 10 or so evaluation examples. And we start to develop error metrics on the evaluation set, so that I can run something, get a number, change something, get a number to tell me how good it is. And this continues to drive more efficient iteration and development. And then only if needed, collect a proper test set to sample, randomly, maybe in an IID fashion to get proper metrics in order to evaluate and drive further improvements. And so I know that to people building machine learning, where we often say, what's a test set metric, right? This seems very strange, but this is actually how many teams are building LLM-based applications. And I am working on applications as well, where we really care about that last 1% improvement. We're working on some applications where we're trying to answer questions and we really want to get it right. And so we do have examples where we have, thousands of examples. And every time we change something, we evaluate it on thousands of examples and see if we can eke out that extra 0.5% improvement. But that's only on a subset of applications where you need that, incremental improvement. And just one other tip. I found that earlier I did a back of the envelope calculation about how cheap it is to use an LLM. Evals. This turns out to be one of the ways to get yourself a very large, much larger, OpenAI bill. But we'll cross that bridge when we see it. Right. And again, just to reiterate, this is all I have on the slide. To step 2, when I say deploy quickly, if a system does a risk of harm, then don't deploy things willy-nilly. If there could be bias, if a mistake could cause damage or harm people, then don't just ship it willy-nilly. Do collect the test set, evaluate it rigorously, audit it rigorously, and make sure it's responsible before you deploy it, right? So just that's a very important caveat to this philosophy. And then to dive a little bit deeper into evaluation, these are some design patterns, kind of steps 4 and 5. How do you develop error metrics as your test set as your evaluation set gets big enough that it starts to get painful to have to read over 11 outputs and then judge 10 or 11 outputs to judge it? So one design pattern is for applications with clear answer, such as sentiment classification, the standard types of machine learning test set accuracy metrics works fine, right? So if an LLM output is this positive or negative sentiment, just measure the percentage accurate. So that works fine. There are also a lot of LLMs with multiple good answers, and a common design pattern is to use another LLM to evaluate whether your first LLM's output is giving a good answer. And you can also feed it a gold standard answer and ask it to compare. So one concrete example, if you have an LLM writing summaries of news articles, you can prompt it to say, compare an expert summary to a submitted summary of a news article. Then give it the original article. Today Brussels announced agreement with EU AI, blah, blah. And if I was doing this, I would use delimiters as Isa said, but I just shortened it for this slide. But I would use delimiters to segment out these things carefully. Then here's the expert human summary. And then here's the LM generated summary in blue. And you can tell it, I'll put A, B, C, D, or E, depending on whether submitted answer is subset or is a superset or disagree, and have a rubric for how to score this. And then you can use another LLM to evaluate your first LLM's output. And this actually, is a way that many teams are using to evaluate LLM's outputs. And GPT-4 is pretty good at this. And when you, if you're evaluating on 1,000 examples and prompting GPT-4 of every evaluation and trying 100 different sets of hyperparameters, your bill for the API calls can start to creep up at that point. So just watch out for that, right? And then let's see, just one last design pattern, which is if you can, this is standard error analysis in machine learning, but if you can break down the key processing steps and evaluate them individually to decide what to work on next, similar to traditional machine learning error analysis with a pipeline, this helps a lot as well. So actually, Jerry Liu at Llama Index and Anupam Datta at Truera had a presentation on, I think, one of the clearest thinking ways of evaluating RAG systems. For RAG, you have to retrieve documents, then use the retrieved documents to generate an answer. And so if RAG gives a bad answer, what went wrong, right? Did it retrieve the wrong stuff, or given the right context, was the generation process broken? And so, Jerry and Upam, have talked about, how to measure, let's see, answer relevance, which is how good is the response to the query, as well as context relevance, which measure how good the retrieved documents are to the query, as well as groundedness, which measures how good is the response that you generate grounded in the retrieved text. And then by using an LLM to look at all of these and to assign metrics, assign scores to answer relevance, context relevance, groundedness. It really breaks down the steps of the RAG system to tell you what part of it is underperforming, and this increases debuggability. So this is one example of evaluation. Okay. All right. So just, I think 3 more slides, then we'll wrap. So open source versus closed source. So I use both of these, very frequently. Closed source models, often accessible via, I guess they're all only accessible via usually cloud programming interface, tend to be very easy to use. The largest, most powerful models are accessible only via closed source, at least in the world today. They're relatively inexpensive, and, maybe some risk of vendor lock-in. And what I often do when developing an application is start with a cloud-hosted closed source model, and see how far I can get. And because of the rapid prototyping, sometimes I'll prototype something and go, gee, that was a waste of time, and then just forget that project. I'm just not going to do that project. And that's fine. But that very rapid speed of development, then sometimes after getting something to work on a closed source model, I would decide to just leave it on a closed source model. I'm perfectly happy with that, right? That happens very often. And sometimes, for various reasons, I might decide I need to use an open source model. It gives you more full control over the model, lets you run on your own device, so on-prem, run on on-prem, PC, edge, and it gives you more control over the safety tuning. While I'm glad that the LLM providers have put a lot of work into safety, I think that some of the closed source models are probably tuned even more aggressively for safety than I personally need for my applications. I feel like, when I drive my car, actually, if it were to rate limit all cars in the world to never go faster than 35 miles per hour, we will have fewer car accidents, but I'm glad that I'm allowed to drive my car at 65 miles per hour. So I feel like sometimes, safety is important, right? I take that very seriously. But the one thing about closed source models is it gives you more control over the degree of refusals and safety tuning you want for your application. But again, there are some, completely uncensored models. So for goodness sakes, please use them only in responsible ways, right? When you have the power. And then you also have full control over the data privacy and access. So when, I was working on some stuff on, that involved PII with, electronic health records, I literally was not allowed to send the EHR over cloud interface in other companies. So we did that, kind of using a locally hosted model to process EHR, because I was not allowed to send an electronic health record, to cloud hosted API. And then actually one downside of this, I should say as well, is it's nice to be run on your own device, but I think that at least at this moment in time, the deployment infrastructure for open source model feels like it's still maturing. I think the hyperscalers are building up better options, but sometimes, when you have your own fine-tuned model or something, finding a way to deploy it, have a low time to first token is still, I feel like the two ecosystem for deployment, especially large models. Your small model is easier, but if a 70 billion parameter model, it's still maturing. But hopefully, I know there are many hyperscalers in this audience and lots of startups in this audience. So hopefully some of you in this audience will go build a better infra for that larger model deployment as well. Right? So it's common design pattern. All right. So with that, Isa and I'll hand it over to Isa to make some future predictions as well.
So to finish, I just want to give a high-level overview of what we can expect for the future of these models. I think the space is moving so fast, as you all know, that it's hard to make concrete predictions with timelines. But in general, we can expect an increase in reasoning abilities, multimodality, as we discussed earlier, just increased tool use and access to real-world information to augment the models. Increased customization. So right now the models don't get to know you, or your use case. I think over time, they should have, memory of how you've used them and, potentially, custom models for individuals or businesses. And then finally, agency. So the ability to take more actions in sequence to complete tasks. So as you're building your own applications, I think it's important to just keep in mind where the technology is headed so that you can build long-lasting products if that's what you're doing, so that you're ready to adopt new technologies as they are developed and released. And so you don't just build a short-term solution. But there are already so many useful things to build with the current models. And not all of them obviously have to be a whole startup or product. I build things all the time for my personal workflows. I have the email example from earlier was actually part of a prompt that I use to process my inbox every day. I even have a job that does that. And I have another thing that adds calendar events to my, my calendar from email. So there's loads of fun things you can build just, in your free time.
So one thing, it's just one more slide of this, and we'll have the panel right after this. I feel like, just to touch on the agency, one of the Wild West areas of LLM application building right now is this whole agents concept, right? Which is, I think of it as autonomous agents that can plan and execute sequences of options. And Isa demonstrated a little bit of this. And in fact, I think when you use ChatGPT and it decides to browse the web and click and scroll down, that's, the LLM deciding to take these actions. And you built that module, right?
The retrieval browser.
Oh, all right. Yeah. She built the retrieval browser that many of you may be using. Right. And I feel like, this idea of using agents, to decide a plan, to carry complex sequence actions, like if you want to book a ticket, well, all the steps needed to do that, right? For travel planning, or if you want to do market research, well, find the competitors, do a web search, find the competitors' web pages, summarize it, distill all that down. That type of agents is, feels like a Wild West area right now, but I think that until 2 months ago, I was saying, exciting. I can't get any of this to work. But just in the last 1 or 2 months, I'm seeing more and more commercial deployments of this. So it feels like it's just on the cusp of starting to work in serious companies and showing it to a lot more users. So I find that very exciting. So something to watch out for. And to me, it's very non-debuggable. I find it very hard to debug. But so there's still a lot of problems. So I find this one of the really exciting cutting shorts. All right. And then just closing thoughts. One thing we did not talk about, but if you haven't already, please learn to use an LLM as a brainstorming partner and productivity enhancer. I use an LLM web hosted or hosted on my laptop multiple times a day. I'm pretty sure, I think it makes me quite a bit more productive, using a web hosted LLM and sometimes a locally hosted one, sometimes as well for highly confidential things. And when I get annoyed at the safety mechanisms of the cloud hosted things. And as developers, one thing I hope you will do is consider using an LLM as a pair programmer. This is a term I learned from Lawrence Moroney from Google. But, rather than coding alone, many developers have a very different workflow. And, it is GitHub Copilot, but it's actually much more than GitHub Copilot, in which I think you heard Isa say if there's an error message, she'll sometimes paste it into GPT-4, have it explain it to you. And I think when I have code that doesn't work, I often use GPT-4 to help me to debug. And sometimes I dual source GPT-4 and Bard, and also to generate code snippets, right? When I'm coding up Streamlit apps, say, I'm often too lazy to look up the right syntax. So I have an LLM generated, plug into my code. Sometimes it doesn't work. Sometimes I debug it myself. Sometimes I have it debug it for me. But this type of workflow, I think there's something very fundamental going on in how all of us act as developers. And I see, many of my friends, are coding in a way that's totally different than any of us were coding like a year ago. And if you haven't already, I think there's a set of pair programming practices I see many people starting to adopt that are making developers much more efficient. And I think GitHub Copilot, it is a good start, but there's actually much more that I see people doing than the kind of template generation that Copilot tends to. And then lastly, I think there's a golden age of AI application building. So, you take responsible AI seriously, but I hope that even as these tools keep on evolving, you will keep learning about them and then go out there and build stuff to help yourself and help others. And if your first few projects, don't work out, so long as it didn't harm others, didn't work out, totally fine, right? You learn from it and then use that to build the next bigger project. And one thing I've been amazed by is the amount of activity, going on, often on Discord with very passionate communities. And these are often people that are, not affiliated with the biggest, best known companies or the biggest, best known universities. There are just lots of people in the world out there right now, often on Discord, hacking up incredibly creative things. And I find that, many of them, they are not attending NeurIPS, right? But they're taking online tutorials and just coding up insanely creative things. In fact, one of the panelists, Mary Ringo Morris, she had built this, AI agents thing. We have AI systems act as characters and just chat with each other and wander around the village, right? And it was cool. I have to, I don't know totally what the purpose of it is, but it's just really cool. And a few days ago, a friend was showing me on Discord, this huge passionate community building all these like character agents, wandering around villages, talking to each other. And again, I don't totally know the point of this, but it is really cool. And I think they could evolve a point in the future. Maybe it's a new form of social interaction. Maybe it helps people loneliness. Maybe someone told me they wanted to use this to simulate human behavior. I think there could be a point in the future, even if I don't personally fully appreciate it yet. And that type of work, often done by passionate people, sitting in a dorm room somewhere or in some other country, just doing this on their spare time. That passion and excitement, I hope all of us can participate in that. And lastly, before I wrap up, just want to acknowledge also, John Santerre, and Boris Power, had also helped a lot, with coordinating and preparing materials for this. So with that, let's just thank you very much. I will also invite up the panel in a second. So thank you all. So while our panelists is coming up, I'll just do brief intros of all of our panelists. Oh, good. So Antje Barth is a principal developer advocate for generative AI at AWS. So she's worked with a lot of teams to build Gen AI applications. She's also a co-author of the O'Reilly books on generative AI on AWS and data science on AWS. She's also worked with my team, DeepLearning.ai, to teach a course, Gen AI with large language models. Tatsu Hashimoto is an assistant professor of computer science at Stanford, and his work focuses on making machine learning robust and reliable, especially LLMs. One of his recent hits was the Stanford Alpaca model, demonstrating how to tune an LLM to follow instructions with very low resources. And this is exciting because it made it accessible to a lot more teams. Graham Newbig is an associate professor at CMU, and he's done a lot of work on LLMs and applications for HCI. And so his work touches very broad range, spanning evals, multilingual models, automatic prompt engineering, pre-trained models for code gen, and using models to aid, using code to aid model reasoning. He actually wrote the original PAL paper, if you know what that is. And then Meredith Ringo Morris, who also goes by Mary, is principal scientist at Google Brain, now DeepMind, and she specializes in HCI, human computer interfaces or computer interfaces and AI. So she has deep experience in LLM human experience. And I also mentioned one of her hits just now of generative agents as an interactive simulator of human behavior. So welcome and thank you all for joining us. All right. So I'm going to start off with one question to each of the panelists. Then we have a discussion, and then we'll also go to audience questions and leave time for all of your questions from anyone. So let me start with Antje. So Antje, you've seen a lot of applications on AWS. What are the major categories of applications you see companies working on? So what are actually people building on top of AWS?
Yes. So I think, Andrew, you pointed out a couple of use cases already in the talk. If I were to categorize all of those applications, I think a lot of companies are looking to enhance their customer experiences. This is where you would naturally see like chatbots, conversational assistants popping up. If you go, like to a customer support site of a company and the little chatbot comes up. This is also where you would see maybe companies improving call center activities, right? Using summarization of interactions between their call center agents, their customers, summarizing, helping them afterwards to review or hand it off to another agent. And then another category I see a lot is how to enhance employee productivity, right? So this is where we would build like knowledge bases, helping internal in the company employees to engage maybe with HR, with product teams, finding internal knowledge data sources and getting answers quickly, helping engineers getting access to information. And then also the code generation, right, or content generation. So helping internal developers in companies to be more productive, as you pointed out. And it's really kind of an exciting world because you can imagine if you're a developer in a company, I'm okay in Python, but my Java times are long ago. So if I were handed an application in Java, I might not know what to do with the application, right? So you can use natural language these days to just say, hey, describe the application for me. What is it doing? And really helping you to get more productive. And then, of course, also around content generation, helping the different teams. In my job role, I write a lot of blog posts, and I still do write them personally. But I use Gen AI, for example, to help me create a quick summary and maybe help me create those social media posts, right, to kind of advertise the blog post and stuff. So roughly, those are kind of the categories I see companies doing.
Awesome. Thank you.
This question's for Mary. So computer-human interaction seems like it's ready to grow dramatically with more sophisticated generative tools. So how can researchers at NeurIPS participate in the human side of this growth?
Thanks for the question. So I think there are a lot of opportunities for advancing the state of the art in human AI interaction. So first, if we think about what's the purpose that user interfaces serve to AI systems? Well, one purpose is bridging what's called the gulf of execution. So this means helping end users have a mental model of what a system can do. And this is a huge challenge right now because our AI models, our generative models, are so general purpose. They can do so many different things, but right now the interface is basically a blank slate. So how do we create interfaces that help convey to end users the range of possibilities for how they might even best take advantage of a model or an application? Second gulf to think about bridging with the user interface is what you might call the process gulf. And this represents the fact that models go about tasks in different ways than people do. So for example, interfaces that support more interpretability over models would be very important for bridging this gulf, as well as that provide then control over that process. And then finally, thinking about the output end, we need interfaces that bridge what's called the gulf of evaluation. So how does the end user assess whether the model did what they wanted it to do? And as models become more powerful, I think this actually gets more challenging. So even with models, state of the art today, think about a model that generates code. Maybe most of us in this audience can write code. So we're capable for ourselves of assessing, whether the output is correct or whether maybe it contains bugs or maybe even dangerous code. But many people might use a code generating model because they don't know how to program. And so how can interfaces help them assess whether the output is in fact correct to their specification and safe? So that's another important challenge of interfaces. And then going beyond interfaces, we can think about what are all the new interaction techniques that powerful AI models might enable. For example, might we be able to finally create high bandwidth, non-invasive brain-computer interfaces as a way to interact with future powerful AI assistants? And if we could successfully create those interfaces, in what cases would it be appropriate to use them? And in what cases might it be creepy or not desirable? So those are just a taste of the many challenges in human AI interaction research going forward.
Awesome. Thanks, Mary. All right. So Tatsu, at Stanford, your group does a lot of cutting edge work on LLMs, and the open source alpaca was a huge hit. So sometimes people worry about universities' ability to do LLM research. What do you think is the right mix of open source versus closed source and academic versus corporation versus hyperscaler research?
I guess, much like maybe many other people here, I feel like my feelings about research in academia have had a roller coaster over the last year. I think right now I'm in the upper side of this. I'm incredibly excited about, in some sense, the state of the field. We can build things that work, like the LLM-based systems. If you step back and think about it for a moment, it's kind of amazing that like a small team in academia can like actually build systems that like do really cutting edge summarization or question answering and like push, the envelope of what's possible. And not only that, there's sort of this like entire explosion in things like post-training research, alignment, evaluation, things like values in LLMs and things like that, that really, I think academia and sort of the open community is really pushing forward. And those things just really very much excite me. And there is very also this aspect that, pre-training research, this kind of like very scale and resource intensive stuff that's happening, that's increasingly going to become the domain of, the largest companies really pushing forward the limits on pre-training. But at the same time, it seems like post-training is equally, if not as important, than pre-training. And those kinds of things really do seem accessible to academic research and to many of us, I think, that are really excited about the development of this technology. And so related to things like Alpaca or our work on sort of studying opinions is really this idea that we can put in a lot of effort and put in a lot of ideas into the post-training phase and be able to shape the way that these language models are going to be developed. And I think that's going to also be true if you're sort of on the side of product development. There's a lot of work to be done in ensuring safety and in ensuring that these systems are actually good for the use cases that you consider that maybe, a one-size-fits-all solution might not really deliver. And so there's always that last mile, and the last mile, I think, is going to be really highly valuable.
Yeah, that's actually good. But if those don't understand, so, pre-training, if you want to do that, budget at least tens of millions of dollars, maybe more, right? Really expensive. But if you take an open source pre-trained based model and fine tune it, instruction tune it, that could be done, at an academic research group with, I don't know, you guys did it for like $100, right? Yeah, $100. Yeah. That's cool. Yeah. Let's see.
Okay, question for Graham. You've been doing a lot of work on evals, so could you please tell us about the latest development in beta evals that you've been looking into?
Yeah, so I really liked Andrew's introduction to evals and how evals are done when building practical systems, because I think actually for some people in academia, you might not think of it that much that way. It's like, we have our training set and our test set and we want to evaluate. But in a lot of practical scenarios, and I've been working with a lot of companies, talking with a lot of people, it really is almost exactly like what Andrew said here. I have one caveat about this though, which is, I feel like if we look at what happened after ChatGPT, the first quarter was everybody trying to figure out what to do, who to hire so that they could actually make, a generative AI-based system. The next 2 quarters were everybody picking low-hanging fruit of what LLMs can do really well right now, like summarization, translation, all these other things. And I feel like the 4th quarter of 2023 has been people pushing the envelope on what things can do, like agents or multi-hop things that do really complex tasks. And it turns out that LLMs can't do everything. When you task them with doing something really difficult, like to give an example, we created a benchmark called Web Arena, which has to do with navigating the web. And you give a command like organize my GitHub repositories so that they're in alphabetical order or something like that. And GPT-4 only gets 14% accuracy on this. And I also see this happening in a lot of companies. Like a lot of companies, they've already figured out the really easy things to do. But now they're moving to the hard things where you can't just expect the LLM-based system to work out of the box. And because of that, I also think the paradigm of really simple evals, just bootstrapping is starting to break down for a lot of, companies as well. And so because of this, I think there's a lot of interesting research on LLM-graded evals, generating data sets, Also, one thing I'm really passionate about is automatically uncovering errors from data sets. So automatically clustering together examples and trying to find places where LLMs are failing in certain ways. And I think all of these tools are going to, like, LLMs open up a lot of new tools for this, but also they're really opaque systems and it's hard to debug them. Prompt engineering is harder than figuring out fine tuning and things like that. So I think it's a really exciting time, actually, from that point of view.
Thanks. So I think we'll just chat here for another, I don't know, 7 or 8 minutes, and then maybe at about 3:55, we'll take it to audience questions. So think about what questions you want to ask any of the panelists. So, one pretty general question. All of you have seen or involved in lots of people starting to build applications on top of LLMs. We'd love to hear your perspectives on advice for people wanting to build things and common pitfalls. So what to do and what pitfalls to avoid that you see in others. Anyone?
I'll give advice from my human-computer interaction perspective. I think the most important thing is making sure that you're building things that are usable by and useful to real people for tasks they care about. And so that might involve actually interacting with target end users before you build anything, right? There are a whole host of different techniques from human-computer interaction that you can be using. You can be using interviews, focus groups, surveys, low-fidelity prototypes, ethnography in order to really deeply understand what it is people want to make sure we're building things that will truly be valued by end users.
And just to add to that, when you're thinking about the use cases, what I see is really, it's important to define a really, really specific and narrow use case, right? So it makes it much more easier when you define what is your evaluation criteria, what is your success criteria, if the use case is really, really specific. And let me just give you a quick example. Let's say you're using LLMs to create product descriptions, right? There's a difference whether you're creating those to create a product catalog. Here you want to probably describe the product in a very neutral voice. You target a broad audience versus you're creating product descriptions to maybe persuade someone to buy the product, right? There you want to maybe narrow down on a specific persona, kind of a recommended item to someone. And you want to make sure here you're really focusing on the specific benefits of the product, maybe for that group of people, right? So really make sure you understand the use case and you specify very, very narrow. That helps you so much down the line with evaluation, with success criteria, also with the risk analysis of the application you're building.
This is also shared with academic research, but I think the one thing that we've seen is just how powerful scale is for all of these models. I think it's important to consider in both sort of research and product development, don't fight scale, right? Like sort of be with it. And in many cases, you're thinking about, doing research or building features or doing things. And you ask yourself, like, is this a feature that's, necessary or as these systems get better, as these systems get cheaper, right? And maybe sometimes you do need to develop those systems here and now, but many of the things that you end up doing, 6 months down the line, there's a nicer model that solves the problems that you were having for you. And maybe you should have spent more time on coming up with better evals or things that really won't be obsoleted when these models inevitably get better sort of year on year.
So I have a really simple thing, which is when you're building a system, when you are going to send a prompt to whatever model you're using, give it to a human. Give it like 3 examples of this prompt to a human and ask them to solve the problem because, GPT-4 is really good and sure it makes mistakes sometimes, but it often gets it right a lot of the time. But it won't get it right if you don't tell it, the sufficient information and sufficient detail to solve the task properly. So if you send it to humans, they'll complain to you. Or maybe OpenAI can make GPT-4 complain to you more often. That might also be helpful, but that will help make sure that you have all the information you need in the prompt and you're actually giving GPT-4 or whatever language model a task it can actually solve.
So I'd love to hear about a topic that you don't have bandwidth to pursue, but you'd love to see members of the audience maybe investigate.
So personally, I'm super excited about the topic of machine unlearning. So I know there have been a couple of talks that are still planned for the week, but I think this is a topic that will be so important over the next couple of months and years probably. How can we make sure if we have to, remove either outdated or incorrect or private data from those big models? So for me personally, this is a very, very exciting topic, and I would love to see more research and more findings on that.
Something that we were just discussing before the event started that's been on my mind. I would love to better understand the robustness of a lot of current findings in the computer science literature. I'm a little bit concerned that we might have something akin to the replicability crisis in psychology in terms of the non-replicability of prompts. So I think there's a lot of work out there right now that's heavily dependent on some very careful prompt engineering that would not be replicable or robust with even minor, add an extra space to the prompt, things that would be semantically indifferent to humans. And so studying that and understanding it, I think, is actually really important for us as a field.
So one topic that I'm generally very excited about is sort of scaling. Like, why has it been that making models bigger just generally makes performance very predictably better, at least in terms of perplexity or other sort of continuous measures of performance? At least in terms of data, it kind of makes sense. I have sort of classical statistical theories that, tell me that. But in terms of the model, it's actually pretty perplexing. And it's very perplexing how consistent it is. So understanding that to me feels like the fundamental, basic question underlying sort of the days that we live in. So answering that would be, the biggest question for me.
I'm excited by people working on open source models that are well documented and we understand everything that went into them. And I think this is good in general, just because we'd like to know what's going into our models. But I think it's also good because it enables research that we're not able to do with these opaque models. Like, why did a model learn something? How much memorization is going on in the models? Like, if you're using a closed model that doesn't have the data available, there's no way you can know this. So the more powerful models that we have, where we do know all of the information, like all of the training data, all of the other stuff like that, I think it will improve our fundamental understanding. So everybody who's working on it, keep it up. If you're not working on it, maybe you should be.
Thank you. That's very cool. Hey, we'd love to throw it all open to all of you for questions.
Hi, thank you for the time. Just a quick question. So there was a lecture by ACM last week about iterative refinement from Stanford. I think that it reverberated during the conversations this morning about some of the looking into black boxes and looking into how LLMs think. You defined two different parameters on the right and on the left associated with evaluation of LLMs. Do you have any thoughts on, I think a lot of people today with generative AI are looking at results and not necessarily knowing how the LLM got to the particular answer. Do you have any particular thoughts on sort of best practices above and beyond what you described today in terms of really understand? I mean, would you align with the iterative refinement, moving away from trial and error in terms of understanding how LLMs are, facilitating answers today?
Yeah, I'm going to give an answer that will sound facetious, but it's actually not facetious. Which is when I'm mystified as to why an LLM came up with a certain answer, I will ask the LLM why it did that. And then maybe just like humans, sometimes they'll tell me the truth, but sometimes maybe it doesn't know itself why it came up with a certain answer. I know it sounds facetious. I have yet to come with a much better solution than that. Maybe someone else here has a better answer.
I mean, what was defined by, I think his last name was Agarwal on the ACM lecture this past week, was using iterative. I mean, there's a lot of dependence on trial and error. And you defined before, answer relevance and context relevance? I mean, would you say a best practice is to create multidimensional vectors that analyze both answer relevance and context relevance? And maybe this is making it overly simplistic. The delta between the golden answer and the answer relevance that is defined for your parameter and the I guess in the latter context relevance, is that essentially how we evaluate LLMs today? Is that a best practice?
So actually, that specific technique, which I learned about from Jerry Liu and Anupam Datta, is a specific error analysis method for RAG, where if you have a pipeline. So we often build applications which process information in stages. So first retrieve relevant documents, then generate text, and we have a pipeline where information moves through a sequence of software modules, then evaluating the individual modules and attributing performance of individual modules is a good, debugging technique.
What we're doing today, we're actually building with Waymo a generative AI based chatbot to evaluate what I've built is the largest corpus of information on the internet for the autism community, to help the autism community travel. There are 8 million people in the autism community, and there are many people that don't travel. Travel is seen as very, very difficult for members of the autism community. So we're trying to evaluate. I'm sorry? Okay, well, I just want to expound on this. This is a really important project for, I think, many stakeholders associated with NeurIPS. So thank you for this opportunity today. Really appreciate it.
So my question is around short-circuiting the path. Let's say you come up with a prompt, you deploy it in one part of some workflow in some funnel of customer journey. And how do you quickly go from there to improving that? Is there a way to say, you talked about exploration mode, you could have multiple prompts to start with, but how can you combine this with, let's say, explore and adapt and fast iteration so that it can very quickly itself start combining the prompts or get into soft prompting or something like that could allow the model to very quickly adapt and learn to optimize that function?
One possible technique maybe in the near future that I'm excited about for that kind of evaluation and iteration is, Andrew jokingly said, what are some of the potential real uses of generative agents besides being in a cute sim world? And I think one of the potential uses is to create synthetic crowds of at a large scale of synthesized agents that could do things like synthetic usability testing, right? And so you can imagine, giving your example system or application to a crowd of 1,000 different synthetic users who have been seeded with different kinds of personas and motivations and scenarios, and having them, run your app through the paces and then give you feedback on it. And I think to enable that kind of application, though, I've seen there are a few startups that claim to market services like this, but honestly, I'm not sure that I would trust those right now. I think what we actually need first is good science to convince us that synthetic crowds can do the same kinds of things as real crowds, and to understand what the trade-offs of synthetic usability evaluations versus real ones are, and how to kind of combine synthesized agents with real people in different stages of evaluation workflows to be most effective.
Yeah, so this is a really good comment, and I care a lot about evaluation, so I'm going to talk about evaluation. But if you have a multi-part system, it's really, really helpful if you can evaluate each individual part separately. So creating data sets that allow you to evaluate each different part separately. Once you are able to evaluate each part, you have two tools available to you. One is prompt engineering and one is fine-tuning, basically. And which one you want to do will depend on whether you can collect a data set and other things like this. But either way, I think it's really important to figure out the subsets of examples that your model is failing on. And for example, I was building a chatbot, and I was browsing through the results, and I found out it was failing on repeating customers' numbers after them and introducing itself properly. at the beginning. So I added 2 examples to the prompt, and suddenly the accuracy went way up. And so I think like identifying the problems that you have has always been my secret weapon. I've been building tools to do that for 10 years now. The most recent tool we built is a tool called Zeno that allows you to browse things very easily in subsegment. But I think figuring out the problems is always my first step to doing that. So that's just my one.
What are some approaches to personalizing applications that use LLMs that you find promising? Like at which layer of the stack do you think it should be done? It could be RLHF, fine tuning, RAG. How do you think we can make LLMs better and more personalized because people use them differently?
Yeah, I think this is a pretty nuanced question. I think maybe my answer here is that at every layer, we need to think a little bit about personalization. Even at the pre-training level, there's a question of, what kinds of sort of very subjective things like values or cultural representations, these kinds of things, are they in the language model at all? Like you need coverage in order to do anything in the post-training phase. So that needs to get handled. And then after that, you probably need RLHF. And I know several groups working on sort of personalized RLHF or like group-wise RLHF preference stuff, basically because people's preferences may be conflicting. So if you're doing a one-size-fits-all RLHF, the only thing you can get is like kind of this very milquetoast generic, I love everybody kind of bot. And then finally, I also think, like sort of prompting style stuff is important to go the last way. You probably can't RLHF for every individual person. So things like the properties of things you like, that probably needs to get prompted in. And so at almost every level, you need to probably start thinking about personalization. And as far as I know, there's sort of research at every single one of these levels and evals for every single one of these levels.
I was wondering what you guys thought about the more new parameter efficient fine-tuning approaches. So we have like some adapters, soft prompt tuning, some LoRa, and they all seem to do similar things. I was wondering whether there's any more principled way to think about which of them is going to work other than just comparing the number of parameters or doing it and seeing the results. Is there a real difference between them, or are there just different ways of moving the parameters around and then it's fewer parameters changed, it gives you a good model and that's what you're looking for?
So we actually did a comparison of these different methods. It's in a paper called on a unified view of parameter efficient transfer learning. And there you can actually connect all of them together. And we did some empirical experiments demonstrating that in some cases, like prefix tuning is better and other things like that. However, everybody is using LoRa. So why is everybody using LoRa? My hypothesis about this is it's one of the only options that's available without any architecture changes. And so it just makes your life so much easier because you're using the same Llama architecture that everybody else is using and no extra code and no extra changes. So I think practically for people building applications, that's the reason why everybody uses LoRa. And if you want a few extra points of accuracy, you might get it somewhere, but I would recommend LoRa in most cases.
Yeah, I would agree. I also wanted to add, I think there's like a limit to how much additional information or kind of how much you can change the model if you're using LoRa, I would say. And the project I'm working on at the moment is like custom models where for specific people customers will continue pre-training and then also do custom post-training. But my hope would be in future, like that would be accessible to like more than just big customers. So like everyone could have something like that.
And just to add to that, I think that would be also like a great research topic on the fast swapping of those LoRa adapters. I was in a great talk yesterday. They talked about, how even smaller models can sometimes outperform like larger ones if they're really fine-tuned on task-specific data sets and then using LoRa. So I think there's also a great opportunity for additional research how to optimize that.
Hello, I'm Wen. I'm from Apple. I have a question regarding the evaluation. So Andrew just talked about several tips to do the evaluation. I just wonder, it looked like those techniques may apply to the offline evaluation. And I'm just curious whether it can be like applied in scale, for example, to ensure it is well covered and the tests are comprehensive. And in addition to that, I just wonder, do you have any thoughts about the online evaluation? I'm not sure whether that applies to the online because it needs a lot of data to ensure the user experience. And do you have any thoughts about what we can do on top of the traditional online evaluation?
Thanks, man. Not sure I have a great answer. So, by online evaluation, you mean sort of real-time evaluation, right? So, yeah, the moderation API that Isa showed, that's one example of something that companies are using to double check their answer for problematic outputs before sending to user. And then, for brand safety critical or mission critical things, you can actually have an LLM generate an output, and it'll take a little bit longer. So the real-time response is hampered. But actually ask an LLM to say, read the answer you just read, you just output, does it have toxicity problems and accuracy? You can actually have an LLM, be prompted to double check its own answer before you send it back to the user. This tends to introduce sometimes a latency problem though, depending on the time to response that you need for your application. But that is done for some critical applications. Oh, and the OpenAI moderation API runs very quickly. So that is used as well.
More meaning for the A/B testing or online evaluation about overall model and user experience.
Yeah, it sounds like a good idea. I don't have any clever to say.
So I think A/B testing is definitely a good thing to do. In addition to that, one thing we didn't talk about at all is how to get confidences out of models, which is an important thing. And there's actually a lot of different ways to do this. The first one, like Andrew said before, is just ask the model, are you confident? This kind of works. The better way to do it is by sampling a lot of responses and checking the consistency in the responses. You probably don't want to do that every single time because it's too expensive, but if you're serving a large volume, you can do it occasionally and just try to identify places where the model is not very confident, sample them and throw them to annotators or something else like that. And there are some good papers on how to do this. I think it's called an empirical, it's not my paper, but an empirical evaluation of calibration methods in large language models or something like that. So I could give an actual reference later.
Well, thank you for a great session. I'd like to dig it a little deeper on what you said about accelerating the deployment phase of the models. Do you or any of the members of the panel have any examples of what are the do's and don'ts of this step?
Boy, I think so long as there isn't risk of harm, I don't think I can think of a single time that I regretted building a prototype and getting in front of users' hands very quickly. I feel like, I've worked on so many products where once it's implemented and you look at it, you go, gee, that's never going to work. And the ability to find it out really quickly is very valuable. And then some of my team knows, when I'm traveling, it turns out I've learned that hotel lobbies have very high foot traffic. It's just one of the things I've learned. So if I want to do user testing, I will often, be sitting in a hotel lobby, and then grabbing random strangers and say, hey, excuse me, do you mind checking out this thing on my laptop or whatever? And sometimes in an hour sitting in the hotel lobby or a coffee shop, actually, when the very first version of Coursera, I was working at a coffee shop, I would constantly grab complete strangers in the coffee shop and say, hey, work on a website. Do you mind taking a look? And people are very nice and take a look and then they'll give me really helpful feedback for shaping the product. So once you have, just now Mary mentioned a low fidelity. Oh, also so many times I would literally draw a low fidelity design on a napkin, literally a piece of paper and napkin. And I will use a test my piece of paper and I'll say, do you mind looking at my piece of paper? This is a thing I'm building. What do you think it's doing? And that very fast feedback gets so much user information. Just one caveat. One thing I've learned as well in my career. In one of my earlier jobs, I managed to make some really good machine learning engineers feel bad for the fact that they weren't a good product manager. And I've learned to not do that. So not everyone needs to learn to be a product manager. But if you're able to do product work and show people prototypes and get feedback, that really helps drive your development process as well.
Yeah, once you have a prototype, there's a whole host of, again, techniques from the human-computer interaction domain that you could use to evaluate it, right? So a simple one is something called heuristic evaluation, where you can find just checklists online. So if you don't have access to the users in the hotel lobby, right, there's checklists online that you can, walk through yourself. Then you could do things like pilot testing, where you can get sort of informal small groups, maybe even just groups of your coworkers or people from the hotel lobby, lobby, right? To try out very early versions and give feedback. You can have people do think alouds during pilot testing, which is very useful, where you have people talk out loud and explain what they're doing while you watch them use the prototype. It can be a good way to get insight into aspects of the interface that might be too cognitively challenging. And then, of course, there's actually releasing prototypes where you can get realistic, more externally valid data about ways in which people are trying to use the system that you didn't expect. You can have all sorts of complex, logging in prototypes to really understand what people are doing. You can bring people into the lab. So there's just an enormous different toolkit of different kinds of usability evaluation methods that can be used alone or in combination.
Thank you for the great talk. So this is Laura. I'm from Amazon, and I work for the risk department. Right now, I want to get some advice on the one thing we're doing. So basically, currently we have manual in the loop in the transaction risk evaluation. So our manual investigators, they take a look at a lot of the internal and the external data source. Like, for example, internally, your transaction history, your account information, a lot of the things, the external one, and also they also leverage the Google search, etc. And meanwhile, we also have long documents like the standard of procedures, which are several hundreds of the pages with different languages. So we are doing the things to automate these kind of the manual work. But right now, what we are struggling is we kind of think about the three different directions, like the prompting, the fine-tuning, and also the RLHF, right? So fundamentally, we need all of the three, but we are like kind of, it's debatable, like with the closed source tools like a cloud tool, we get very good performance, but we can't fine tune the result based on our manual feedback. And with the open source, the performance is not as good. So we want something ideally, like we can fine tune. And meanwhile, we can give prompt, not in a few short way, but always, like for example, the standard procedure is several hundred. We want to prompt once and let it memorize long text, right? And then for also giving the feedback from the real human. So I want to get some advice, like which should be the right direction we should move forward and focus on, if like we just want to build some success thing in production for real time.
Well, so I think we'll just do this one. I think we should wrap. So apologies to everyone else. We didn't, but we'll be around and can take a few more questions offline. But just some generic advice. I found that when building an application, there are a lot of details. I don't know the specifics well enough to give concrete advice, but I found that one mental framework we often use is look at how humans process information. People will process information step by step, read this, then have an if statement, then do that, then do that. And then if you have a mental model for how the step-by-step process a human would do to carry out that task, then it becomes easier to do the error analysis, to see step by step where does the LLM or other tool fall short of the human, because that often gives you a tool to decide where to focus your efforts. And then unfortunately, a lot of things like selecting the model, there are, I don't know, like the Hugging Face leaderboards, Percy Lang at Stanford, the homework is really, goes really deep in evaluation as well. So there are tools like that. But then at the end of the day, I think most teams end up treating it as an empirical thing. And when we in machine learning say it's empirical, it just means don't know what we're doing, just try a bunch of stuff and see what works. But saying it's an empirical process sounds better, I guess. But that is the process. All right. Hey, so I think we're running a little bit over. So out of respect for everyone's time, let me just apologize, couldn't take everyone's questions. I think the panelists will be around a little bit longer. We can hang on and chat if others have questions. But let me just thank our panel very much again, and thank and Isa and I want to thank all of you for coming to this NeurIPS tutorial. So I hope you will go back and, these are amazing tools building on top of LLMs. I hope you take what you've learned, or not, but just go and build some things to help yourselves and help others. Thank you all very much.